Hello everyone. In this video, we'll make our program even more game-like by having it respond to user input. We'll have it move the falling block right and left when we press the right or left arrow key on the keyboard, drop the block down instantly when we press the down arrow key, and rotate the falling block when we press the up arrow key. Let's get started, shall we? To have our program respond to keyboard key press, we will use the so-called key bindings, and we will do that in the game form class, so let's switch over to it. We'll write the code for key bindings in a separate private void method named initControls. To make the key bindings work, we need to add some data to the so-called input map and action map. But before that, we need to get those maps and store them in variables of appropriate types, specifically input map and action map. And of course, we need to import the classes. Now, to get the maps, we need to call respective methods on the so-called root pane of the game form. It might seem confusing, but this is just how it is. And this is how key bindings work. To the input map, we add keystrokes. What is a keystroke? A keystroke is an action performed using the keyboard. For example, when we press the space key on the keyboard, we perform an action using the keyboard. Every keyboard key has its own keystroke that we can use to make our program react in a certain way. So when we add a keystroke to the input map, we also need to give that keystroke a name. Then we add an action to the action map and give that action a name as well. Finally, our program gets both maps and matches the keystrokes with actions using the names that we gave the keystrokes and actions. Why can we not just add both keystrokes and actions into the same map, you say? Well, there's a reason for that, which we will not cover in this video. Now, how do we add keystrokes to the input map? To do that, we need to call the put method on the im variable. The put method takes two parameters, a keystroke and an object. To get the keystroke for a certain key, we can use the getKeystroke static method of the keystroke class. As a parameter, the method takes a string that represents the keystroke. For example, the string for the right arrow key is right, all caps. Now, the second parameter for the put method must be of the type object. In Java, any reference data type is an object, meaning all reference types in Java inherit from the class object. In other words, we can pass any data type as a second parameter to the put method. But let's use a string, like this. Please note that this string serves as a label associated with this keystroke. The content of the string can be anything, not necessarily the word right. Let's now do the same for the remaining three keys. And now it's time to fill the action map. To add an action to the action map, we can also use the put method. Just like the put method of the input map, the put method of the action map takes two parameters, where the first parameter is the key, the string labels that we gave to the keystrokes. So we can add 4 method calls, one for each of the keys, like this. Now, as a second parameter, the put method requires an action. And an action in Java can be represented by an instance of the abstract action class, which we also need to import. And now NetBeans is yelling at us that abstract action cannot be instantiated. And this is just what it says. Some classes in Java cannot be instantiated. Such classes are called abstract, and they have the word abstract in the header. To keep it simple, let's just take it for granted that abstract classes cannot be instantiated, but they can be extended. In other words, we can create a different, non-abstract class, say my class, and have it extend the abstract action. And since my class is not abstract, we can instantiate it and pass the reference to the put method as a second parameter without NetBeans yelling at us. Cool. There's an issue though. We cannot have one class represent 4 different actions that we need to add to the action map. Meaning, since we need to add 4 actions, we need to create 4 separate subclasses of the abstract action class. Something like this. Looks sloppy, doesn't it? Especially because these myClass classes will never be used more than once, here inside the initControls method. To make our code less sloppy, we can use the so-called anonymous classes. An anonymous class is a class without a name, and here's how we can create and instantiate an anonymous class that inherits from the abstract_action class. Please pay attention to this weird-looking combination of brackets at the end. Now, NetBeans is yelling at us that we do not override an abstract method of the abstract_action class, so let's do override it. Delete the body of the method, and space it out a bit. In one of the previous videos, I promised that I would further explain this invoke_later method call, specifically the parameter that is passed to the method. So what gets passed to the invoke_later method as a parameter is an instance of an anonymous class that sort of extends runnable and overrides its run method. It sort of extends runnable because runnable is not a class but a so-called interface, and in this example, runnable is not extended but implemented. But the main idea is still the same, so to keep it simple, let's just leave it at that. Now, before we continue, let's delete these myClass declarations. And look at this weird-looking piece of code. What it does is it adds an action to the action map. The name of the action is write, and the action itself is represented by an object of an anonymous subclass of the abstract_action class. And as some of you have probably figured, the code that this action represents should go inside the action_performed method body. Just to test it, let's have our game print some text when the arrow keys are pressed. Now, if we want the initControls method to be called only once at the start of the program, where in code should we call it? Right inside the constructor. And if we run our program, we will see that it prints respective text when we press arrow keys on the keyboard. Now, what do we replace these println method calls with? Well, we currently don't have anything that fits nicely in there, meaning it's time we create some more methods that will get called when arrow keys are pressed. The question is, where do we declare these methods? All of the methods in question will be responsible for moving or rotating the following block. And what class is currently responsible for doing something like this? The GameArea class. So let's switch over to the GameArea class and add some more methods to it. We need a public void method that will move the block to the right and to the left. We need another method that will drop the block down instantly and rotate the block. Let's now switch back to the GameForm class and call these methods using the GameAreaGA variable. Now, using the moveBlockDown method as a reference, can you think of how we should approach moving it to the right and left? We already have moveRight and moveLeft methods in the Tetris block class, so we can call them here. If we now run our game and try to move the block right or left, it will in fact move as we say. But it's sort of laggy, meaning when we press the left or right arrow key, the block doesn't move right away. Any idea why? Please look at the moveBlockDown method and try to figure out. we need to repaint the game area after moving the block right or left by calling the repaint method. And now our blue block is more responsive to key press. Now how do we make the block drop down instantly? We can call the move down method on the block until the checkbottom method returns false. And after that, we need to make sure the block is painted at the new location. If we run our program, we will see that the blocks drop down instantly on the down arrow key press. An issue here is that the blocks do not stack on top of each other, and we will get to fixing that in a bit. Now let's make the block rotate. To be consistent, let's implement the rotate block method similarly to how we implemented the other three methods. In other words, to the Tetris block class, let's add a method responsible for rotating the block. And call this method in the rotate block method of the game area class. Now let's switch back to the Tetris block class and think of how we're going to make the block rotate. Any Tetris block has 4 different rotations: 0 degrees, 90, 180, and 270 degrees. Since the shape of the block is represented by an array of arrays, we can add 3 more shapes that will represent the block in 3 other rotations. Alright, but then how do we switch from one shape to the next? Well, first of all, to be able to switch shapes, we need to store them. What data type should we use to store arrays of int arrays? Surprise, surprise, we can use an array of arrays of int arrays. So let's declare an array member variable and name it shapes, and instantiate this array in a separate method named, say, initShapes. How many arrays of int arrays will it store? Since we have 4 different 90-degree rotations, the shapes array has to be able to store 4 elements, 1 for each rotation. Before we move on, let's call the initShapes method inside the constructor. Next, to be able to switch to the next shape, we need something to tell us which of the 4 shapes is currently active. So let's declare an int variable to store current rotation. Now inside the rotate method, we will increment the current rotation variable and assign the variable shape the element of the shapes array at the index current rotation. An issue here is that current rotation must not exceed 3, since the shapes array stores 4 elements. In other words, when current rotation exceeds 3, it must be set back to 0. Now if we run our game and try to rotate the block, we will get a null pointer exception. Any ideas why? It happened because we haven't instantiated the 4 arrays of the shapes array, leaving all 4 of them as null, meaning the shapes array stores 4 null elements, and we can't do much with something that's null. So let's fix this. What we need to do is we need to get the shape array passed to the constructor, sort of rotate it 4 times, and store the rotation arrays in the shapes array. Now how do we rotate the initial shape array? A 90-degree rotated version of the array R1 is the array R2, which has the number of rows equal to the number of columns in the R1 array, and the number of columns equal to the number of rows in the R1 array. Also, each row in the R2 array is a column in the R1 array. But how do we do this in code? Well, we will need a loop that will be executed 4 times, 1 for each rotation. Inside the loop, we will instantiate a new array of int arrays for the rotation of the shape. And the number of rows in the new array will be equal to the number of columns in the original shape array, while the number of columns in the new array will be equal to the number of rows in the original shape array. Then we need to traverse this newly created array, and since it's an array of arrays, we need a for loop inside another for loop. And inside the loop, we assign the values to the newly created array using the original shape array. Please pay attention to the indexing that we use for both arrays. Make sure you understand how it works. Pause the video if you need. Now, because at the next iteration, we'll have to rotate the current shape, the one that we've just created inside the loop, we should assign the current shape to the shape array, like this. Finally, every time the block is spawned, let's set its rotation to 0 and assign the variable shape the shape at the respective index. Please note that we must do this before we set the y and x coordinates of the block, because the height and width of the block depend on the shape of the block. And if we run it, we'll see another null pointer exception. This one is a bit unfair though, and it happened because for whatever reason, NetBeans decided not to compile the code that we just added. How do I know that? Here, this wrench icon next to the name of the file means that this file needs to be compiled. If you got this error as well, here's how we can fix it. One way to force compilation is to press this Build Project button. As you can see, the wrench icon disappeared. And if we run GameForm now, it will not throw the exception. And now when we press the up arrow key on the keyboard, the block rotates. Cool. But it's laggy. Does anybody remember how to fix this?
Of course!
Right, we need to call the repaint method in the rotate block method of the game area class. Now, currently we can move the block outside the game area, which isn't good. And in addition to that, the blocks do not stack, but sort of go right through one another. Let's fix the first issue first. Does anybody remember what we did to prevent the block from falling through the bottom edge of the game area? We added the checkbottom method, whose job is to check whether the block can be moved downward. Let's add similar methods that will check whether the block can be moved right or left. To check whether we can move the block down, we call the getBottomEdge method of the Tetris block class. So let's add to the Tetris block class methods that will return the left and right edges of the block. For now, let's have both methods return 0. And switch back to the game area class. So in the checkLeft method, similarly to the checkBottom method, we will compare the left edge of the block with the block must not go beyond the left edge of the game area. So what number represents the left edge of the game area? Right, 0. So if the left edge of the block is right at the left edge of the game area, the checkLeft method should return false. And it should return true otherwise. Now let's write the checkRight method. What number represents the right edge of the game area? Right, the number stored in the grid columns variable. Now that we have checkLeft and checkRight methods, where do we call them? Where do we call the checkBottom method? We call the checkBottom method in the moveBlockDown method. And similarly, we can call the checkLeft and checkRight methods inside moveBlockLeft and moveBlockRight methods, like this. We can also shorten the conditions like this. Now, there is no point running this program now since we haven't written the getLeftEdge and getRightEdge methods of the Tetris block class. Let's do that now. So first of all, what number represents the left edge, or the leftmost column of the block? Right, it's x coordinate. So the getLeftEdge method should return x. Wait a second, some of you might say. The getX method also returns x. Can we just use the getX method instead of getLeftEdge? Yes, we can, but we're not going to do that, and I will explain why in a bit. Now, what number represents the right edge of the block? This one is a bit tricky. Technically, the right edge or the rightmost column of the block is represented by x plus the width of the block minus 1. So if the x-coordinate of the block is 4 and the width of the block is 2, the x-coordinate of the rightmost column of the block is 4 plus 2 minus 1, which is 5. But let's have the method return just x plus the width of the block, and I will explain later why. If we now run our game, we will see that the block now doesn't move outside the game area. Great! Now before we get to fixing the other issue, with our blocks ignoring each other, let's switch to the game area class, and I will give you the two promised explanations. First, in the checkLeft method, we call the getLeftEdge method of the Tetris block class, which returns the same value as the getX method. But if we replace the getLeftEdge method call with getX method call, like this. I don't know about you, but to me this seems less self-explanatory. In other words, sometimes having two different methods that return the same value might be worthwhile, as it might improve code readability. The other explanation is related to the getRightEdge method. Whereas, technically, the x-coordinate of the rightmost column of the block is x plus block width minus 1, we omitted the minus 1 part because we omitted it here in the checkRight method. I mean, if we subtract 1 in the getRightEdge method, we'll have to subtract 1 from the grid columns variable as well. But we can just omit this minus 1 and the math will still work. Now let's fix the issue of the blocks not stacking on top of one another. So to make the block stop when it touches another block, when checking whether the block can move left, right, or down, we must also check whether there is another block immediately to the left, right, or below the block. In other words, we need to further modify what methods? Right, the checkBottom, checkLeft, and checkRight methods of the GameArea class. Let's start with the checkBottom method. What changes do we need to make here? Well, to make sure that the block can move downwards, we need to make sure that the background cells immediately below each column of the block's shape are null. And if at least one of the columns of the block's shape has a non-null cell right below it, the block must not move down. Before we get to code writing, please look at these diagrams again and make sure you understand the idea. Now let's try to code this idea. So we need to check each column of the block's shape. For this, we need to get access to the block's shape. Then we need to traverse the shape array, and we need to traverse it first by column and then by row. In addition, when traversing the shape array by row, we should do it bottom up or backwards, like this. So we traverse each column bottom up until we find a non-zero element. Then we need to check the element of the background array located immediately below the non-zero element of the shape array. And if that element is not null, the method should return false. And otherwise, we need to terminate this loop by adding a break statement. We should terminate it because there is no need to continue checking other elements in the same column of the shape array. If we run our game now, we will see an array index out of bounds exception. Why did it happen? Well, remember, when the block is spawned, its y-coordinate is negative because it's located above the top edge of the game area. And when the block is not completely visible in the game area, it is possible for this y variable to be negative. But since an array index cannot be negative, we get this out-of-bounds exception. To fix this, we need to run an additional check to make sure the value of the variable y is not less than 0. And if it is less than 0, we do what? Since there cannot be a non-null cell in the background array when the y index is less than 0, we can just give up on checking the entire column of the block's shape. So we can terminate this loop by adding another break statement. Now, what does the break statement do? The break statement is somewhat similar to the return statement. However, while the return statement terminates the entire method, the break statement only terminates the loop. What's also important is that in case of nested loops, like we have here, the break statement only terminates one loop, the one inside which it's written. And now if we run our game, we will see that the blocks now stack on top of one another without any exceptions. Cool. Now, there are still issues. One of them is that the blocks can pass through other blocks when we move them sideways. Looks kind of funny, but let's still fix this. To do that, we can modify the check left and check right methods similarly to how we just modified the check bottom method. But instead of traversing the shape array by column, we will traverse it by row. And then by column. Also, for the check left method, we need to traverse the shape array left to right, meaning the inner loop counter call starts at 0 and gets incremented while it's less than the width of the block. Next, since we need to check the background array to the left of the block, we subtract 1 from the variable x, and we do not add 1 to the variable y. For the check right method, we traverse the shape array of the block right to left, meaning the inner loop counter call starts at width minus 1 and gets decremented while it's greater than or equal to 0. And because we need to check the background array to the right of the block, we add 1 to the variable x instead of subtracting it. And now if we run our game, we will see that the blocks do not ghost each other anymore. So step 4, complete. Alright, let's summarize what we did and learned in this video. We used the so-called key bindings to make our game respond to keyboard key press. So we can now move and rotate the falling block using the arrow keys on the keyboard. If you want to use keys other than the arrow keys, feel free to do so by modifying the initControls method of the GameForm class. We also made our Tetris blocks stack on top of one another by adding additional logic to our program. As our program gets more complex, it gets more overwhelming to keep track of all the changes that we make. And I would like to encourage you to take your time and make sense of the code that we add. And this is it for this video. In the next one, we'll make our game clear, complete lines. See you then. Bye.